So I thought I'd demonstrate octane. How to find the isomers of octane, or yeah, just there's actually 18 of them in total, okay? So I know that from a textbook, but also from searching. So this is 1, 2, 3, 4, 5, 6, 7, 8, okay? Next one is 1, 2, 3, 4, 5, 6, 7. One off number 2. Then 1. That's 7 in a row. One off number 3. Then 1, 2, 3, 4, 5, 6, 7. One off number 4. Okay. Then you got try 6 in a row, because if you put carbon to this one, it just becomes that one again. So this is the maximum you get with 7 in a row. Try 6 in a row. Longest chain. 1, 2, 3, 4, 5, 6. So you need 2 more. 7, 8. Okay. And then 1, 2, 3, 4, 5, 6. So that's position 2, 3. You could try position 2 and 4. Okay, so that's another one. That's definitely different from all these, and it's C8, H, 18. 3, 6, 9, 12, 13, 14, 15, 16, 17, 18. Okay, that's the number of carbons. So next option is, this is 1. You're a third of the way there. Next option is 1, 2, 3, 4, 5, 6. Okay, so I've done 6, position 2, 3, position 2, 4, position 2, 5, that's 7. So this is the way I film. I just write down all, this is how I search for isomers. I just write down all possible structures. When you got 7 in a row, and 6 in the longest chain, and 5 in the longest chain, and 4 in the longest chain, and 3 in the longest chain, I just keep working down all the possibilities. So next options are, so we've done 6 in a row. Next, 1, 2, 3, 4, 5, 6. So you could have 1, 2. That 1, 2, 3, 4, 5, 6 in a row with 2 off number 3. What happens if you have 1, 2, 3, 4, 5, 6, 7, 8? Well, that's actually 1, 2, 3, 4, 5, 6, 7. That's actually number. That's the same as having 3, 4, 5, 6, 7 in a row with 1 in carbon 3, which is the same as this one. Okay, that's 7 in a row with 1 off carbon 3, so that's not 1. Okay, so you got this one, and then you got 1, 2, 3, 4, 5, 1, 2, 3. Okay, 5, 1 in carbon 2, 2 coming off carbon 3. And then you've got 1, 2, 3, 4, 5. And then you could have 1 coming off that one and 2 coming off that one. 5, 6, 7, 8. Okay. And then another option, 1, 2, 3, 4. You have 1, 2, 3, 4. Okay. 4, 5, 6, 7, 8. So you got 3, 6, 9, 12. 3, 6, 9, 12. 30, 40, 50, 60, 17, 18. So that's C8, H18. Okay? So that's another option. And then you've got another option, which is having 4 it's actually 5 in a row, this. 1, 2, 3, 4. 1 coming off there, 1 coming off there, and 2 coming off there. So there's actually 1, 2, 3, 4, 5, which is 2 coming off carbon 2, and 1 coming off carbon 3. So you've got 5 in a row, which is 2 coming off the second one either side, 1 coming off, 2 single carbon coming off number 2. This is 5, so not carbon 2, that's not the same as that, and 2 carbons coming off, an alkene basically, coming off carbon 3, which is basically different from, sorry, 1, 2, 3, 4, 5, sorry, 5, okay? You got the single carbon coming off each side of the second one, that's not the same as that one, or that one, and a single one coming off the third one, which is not the same as that one. Okay, so this is unique. Okay, so that's 7, 8, 9, 10, 11, 12. Okay. And then you've got, so what's the next ones? Then you've got, I then realised you have 1, 2, 3, 4, 5, 6. Okay, have I got that one before? So 6 with 1 coming off 3 and 1 coming off 4. This is 6. That's 1 coming off 2 and 3, that's different. So I had 2 and 3, 2 and 4, 2 and 5, but I hadn't got, so that's second carbon, fourth carbon, second carbon, fifth carbon, but I've forgotten about third carbon and fourth carbon, so that's 1, okay? So that's number 13. That's different from these two, from these 3. And then it's also different from this one, because 1 coming off number 3, 1 coming off number 4, and it's different from that one. But that's not 1. Okay, and then I realised you have also so there's 1, 2, 3, 4, 5, 6. And then number 3, number 4. Is that different or is that the same? I think I've just realised that I've done a duplication. No, that's actually repeating that one. There's not 1. So you've got 1, 2, 3. What? That's also repeating that one. You got 5, 6. That's different because if you rotate it, you're not creating this one, okay? And then you've got so that's again different because if you rotate it, you're not creating this one. Okay? So that's a new one. And then you've got So that's, rotate that, that's a carbon's 2 and 4. Flip that over and that is different from this. So that's a new one. 2 and 5 are being occupied, but if you flip it over, that's different from this. So that's a new one. 2 and 3 being occupied. If you flip this over, that's different from this. So yeah, so this one's different from this because, sorry, this one's different from this because if you flip it over, you don't create this. That one's different from this because if you flip that over, you don't get this. This one's different from this because if you flip it over, you don't get this, okay? So is that total of 18? You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 15, 16, 17, 18. I think that's the isomers. If I see, yeah, so you've got, if I find an error, I'll remove the video and redo it, but I think that's it, okay? As I was going over this, I thought I made some mistake. I think I spotted some errors, but that's all 18, so it takes a lot of practice and a lot of work. I wrote down ones like, and then realised that actually is the same as number 6. Okay, so that doesn't count. And also wrote down okay, that's 6 in a row with 2 coming off number 3, which I 2 coming off number 3, which is 1, 2, 3, 4, 5, 6. 1, 2, 5, 6, 7, 8. So after studying this, I drew this one, which actually is new because it's 6 carbons in a row with 2 coming off the third one. Okay, that's a new one. But this one I wrote down as wrong because it's actually repeating 15. Got a single one coming off 2 and 3 either side. Okay, so that's wrong. So that actually is probably number 18. Okay, it takes a lot of work to find them as you're seeing. And if I put these 2 on the third position, it simply repeats this. It's like flipping it through that axis. Okay, so that doesn't, and if I move these 2 to this position, it's basically repeating, I think, this one, because if you put it in this position, you go 1, 2, 3, 4, 5, 6, 7, with a single one coming off the third carbon, which is basically what this one is. So this one is an 18th, so it's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, okay? So yeah, there's and for the record, there are, if you like to feast your eyes, if you have a lot of spare time and you want to practice finding isomers, for C10, H22, there are 75, which I'm not going to search for, okay, because I'm not crazy. By the way, C9, H20 has 35. C15, H42 has 3000, sorry, C15H, 15 times 2 is 30, 32 has 4347, C20H 42 has 366,319, and C30H, 30 times 2 is 60 plus 2 is 62, so C30H62, which is rubber, plastic rubber, that has 4,111,846,763 isomers. So if you want to search for these, it will probably take you more than you could live, longer. It probably take you, I think it works out at several billion years, and you'll be, I don't know how this has worked out, possibly with a computer, with some formula, math formula, I don't know. There may be a mathematical formula, or somebody may have used a computer, but the textbook I'm getting this from was published about 1990 or 1980s. Modern computers back then were not nearly as good as they are now, so I don't know how this has worked out. It may be done with a mathematical formula, but it could have been just done by the computer searching all possibilities. Somebody maybe wrote a program to look for the isomers, and the computer could probably do it quite easily. Anyway, there's 4,111,846,763 isomers for C30H62, okay? So you can, lots of practice for you. Okay, have a good, hope that helps.